Hello, Algebra 1. Welcome to part 1 of QM3. QM3 encompasses parts of expressions, also some interpreting some expressions, and then we're going to do creating and solving equations. It's all kind of one big thing. It's going to look weird because it's over the course of two guided note sections. We won't do everything in both guided note sections. So with that said, let's go ahead and get started for part 1. Part 1, modeling with expressions. Yeah, QM3 part 1. It's right there. All right, what do we have? It says interpreting parts of an expression. You know when you got this many gray highlighted things, you know it's going to be a big thing. So let's see, we got expression, we got terms, we got coefficients, we got numerical expression and algebraic expression. What did those mean? Okay, let's go with expression. I have said this many times so far. We did this in PA2 also. We talked about expression versus equation. An expression, you got some math things going on, but no equal sign. Now, and it could be, again, you got operations, numbers, and variables. When you got terms of the expression are the parts that are being added. But what if they're subtracted? Good question. We'll get to that. Coefficient is the number multiplying the variable. So in other words, the numerical factor of the variable term. We'll see what that looks like in reality here. We've got, when it comes to expressions, we have numerical expressions and algebraic expressions. Well, let's look with the root words here. Numerical sounds a lot like numbers. So that's why it contains only numbers. And algebraic has at least one variable because it's algebra. And in algebra, we just added letters. It's all right. It's not English class, I know, and I've heard that before. It's okay. It's okay. All right, let's go ahead and do this business here. This first one says, identify the terms and coefficients of the expression 8p plus 2q plus 7r. What do we got to do for terms? Terms are the things that are added together. So what's added together? 8p, 2q, and 7r are added together. We have 8p, 2q, and 7r. Coefficients. Coefficients are the numerical factor of a variable term. They're the numbers multiplying the variables. So the coefficients of these three things are, what's the number multiplying p? 8. What's the number multiplying q? 2. What's the number multiplying r? 7. Terms and coefficients. Terms and coefficients. You can think of this as basically your one level. Identifying terms, identifying coefficients. We'll talk about one more thing, and variables, but we'll talk about one more thing here. Right? If I said what the variables are here, variables, my letters in here, you would tell me that that would be P, Q, and R. Okay. What's the next step, Mr. Brayman? Great question. It says identify the terms and coefficients of the expression. Again, expression, no equal sign. 18 minus 2x minus 4y. Oh, we got subtraction. It says since this expression involves subtraction, rather than addition, we're going to rewrite the expression as the sum of the terms. When we talk about sums, we're talking about addition here. We have 18 minus 2x minus 4i. We could rewrite as 18 plus negative 2x plus negative 4y. Remember, subtraction, and I think Mrs. Hunt probably said this, there's no such thing as subtraction. And she's absolutely right. We can turn subtraction into addition, and we just did. Nice. So our terms, again, the things that are added together, we have 18, we have negative 2x, and we have negative 4y. And the coefficients are, drum roll please. I don't know if you did a drum roll or not. You can pretend like you did. 8, let's see with 18. 18 is not multiplying a variable. So 18 is not a coefficient. What's being multiplied by variables? We've got negative 2x, so negative 2 is the coefficient, and negative 4 is the coefficient for y. All right. Now we got some combination work going on here. Identify the terms and coefficients in the expression 2x plus 3y minus 4z plus 10. We've got both subtraction and addition. Subtraction, they don't make these blanks big enough for me. Rewrite the expression as this sum. We're going to do addition again. So 2x, still 2x, still plus 3y, but instead of minus 4z, we're going to say plus negative 4z plus 10. So the terms, again, the terms are the things that are added together. So 2x, 3y, negative 4z, and 10. And the coefficients, again, if there's no variable with it, it's not a coefficient. So 10 is not a coefficient. It's not multiplying a variable. 2 is multiplying x, 3 is multiplying y, and negative 4 is multiplying z. I guarantee somebody's going to make that mistake on here and forget the negative sign and be really upset with themselves for coefficients. If I asked you what the variables were, which I will on a test, I would say my variables are x, y, and z. Okay, let's use this for a second here. This is going to ask us about factors on the next page. We'll talk about that. That's not my emphasis this time. We're just going to make mention of that here just to let you know. Tickets to an amusement park are $60 for adults and $30 for children. If A is the number of adults and C is the number of children, then the cost for A adults and C children is 60A plus 30C. What are the terms of the expression? What's added together? That would be 60A and 30C. What are the factors of 60 and A? In other words, what's multiplied together? Well, it's 60 and A. What are the factors of 30C? Well, it's 30 and C. It's what's multiplied together. What are the coefficients? What are the numbers multiplying your variables? They are 60 and 30. Interpret the meaning of the two terms of the expression. Well, the first term is 60A. And what does 60A mean? It's 60 times A. A is the number of adults. So if I knew how many adults there were and I multiplied it by 60, I'd get the total cost for adults. Total ticket cost for adults. We are more expensive than the children. And the children, 30C, that's a bad zero. 30C, 30 times the number of kids, because that's C, that's how much the kids cost. Total cost, I mean, I didn't mean that as how much the kids cost. Total cost of tickets for kids. You can't sell people. Total cost of the tickets for the kids. And again, we're not selling adults either. We're not selling people. It's not something we do. Okay. The price of a case of juice is $15. Fred has a coupon for 20 cents off each bottle in the case. The expression to find the final cost of the case of juice is 15 minus 2/10 times B, where B is the number of bottles. What are the terms? If I rewrote this to do an addition, this would be 15 plus negative 2/10 B. Oh, I like the leading zeros. There we go. What are the terms? I just rewrote this into an addition. I've got 15 and negative 2/10 B. Continued on the next page. There we go. What are the factors of the term? What are the factors of the term? Well, why don't you take a quick second and think about it? Now that you've thought about it, What are the two factors here? Well, the factor, we've got a 15, and that's it. It's just 15. It's not multiplying anything. So 15 is the only factor of the first term. And we've got negative 2/10 and b are the factors of the second term. Do both terms have coefficients? Is that 15 multiplying a variable? No, it's not. So no, 15 is not multiplying a variable. Fifteen is not multiplying a variable, but we do have a coefficient because we do have a value multiplying a variable, and that value is negative 2/10. So what does this expression mean? What does 15 minus 2/10 b actually mean? And what it means is it's the cost after buying B bottles, the total cost. Because for every bottle that he buys, in this case, it goes down by 20 cents. So it's the total cost of buying B bottles. All righty. I'm going to have you do the two reflect questions. Oh, actually, I'm going to do I want you to think about one, check it with your work. I'm going to do number 2. What is the coefficient of the expression b in b plus 10? Like we talk about, if this looked like this, if this was 6c, you would tell me I have how many c's? I would have 6 c's. In this case, there's no number multiplying the b. So how many b's do we have? We have 1 b. So the coefficient is, whoa, that's a funky E. I have 1 as my coefficient. It's 1b. 1. I have 1b. 1b. Sometimes it just randomly shuts off. Okay. 1b. I promise you, I promise you, I promise you, I promise you, this concept will be on the test. Promise, promise, promise. Okay. Interpreting algebraic expressions in context. Here is an important one. This is a lot of words, and it's a lot of words that, when you boil it down, pretty straightforward, and that's okay. Let's look at what this says. It says, in many cases, real-world situations and algebraic expressions can be related. The coefficients, variables, and operations represent the given real-world context. So interpret the algebraic expression corresponding to the given context. Curtis is buying supplies for his school. Yay, Curtis. He buys P packages of crayons at $1.49 per package and Q packages of markers at $3.49 per package. What does the expression $1.49p, 1.49p, plus 3.49q represent? Well, first of all, what does the term 1.49p represent? What's that coefficient mean? The coefficient represents the cost of a package of crayons. So, however, if I buy 6 packages of crayons, it'd be $1.49 times 6. But we don't know how many we're going to buy, so that's we just do this general variable, and in this case, we're calling it P. So 149p is the total cost of crayons. 349q is the total cost of Q packages of markers. The coefficient is the price per package. So this entire expression, it's the total cost of buying P packages of crayons and Q packages of markers. At the same time, we got this business down here. Jill is buying inkjet paper and laserjet paper for her business. She buys 8 more packages of inkjet paper than P packages of laserjet paper. Oh, we're going to make our own expressions. All right. And inkjet paper costs $6.95 per package, and laserjet paper costs $8 per package. What does the expression 8p plus 6.95 times p plus 8 represent? Notice there's only one variable. That's weird. Why? Okay. Let's look at the first term. We've got 8p. And then what does the coefficient 8 represent? 8p is the total cost of, well, what's p mean? Laserjet paper. And laserjet paper costs $8 per package. So the term 8p represents the cost, the total cost of p packages of laserjet paper. Whew, laserjet paper. And that 8 is the cost per package of laserjet paper. Now we get into the fun part. We've got to interpret the meaning of the second expression, 6.95 times p plus 8. What do the factors, again, factors are the things multiplied together. What does 6.95 represent? And what does p plus 8 represent? Now, we're going to write this. I think they're the blanks on the next page. Okay, here we go. The term 6.95 times p plus 8, well, that p plus 8 was not our laserjet paper. That was our inkjet paper. Let me double check here. Because inkjet paper, she buys 8 more packages of inkjet paper than p packages of laserjet paper. So p plus 8 indicates how many inkjet paper packages she bought. So the entire term represents the cost of inkjet paper. And why is that? 6.95 represents the cost of one inkjet paper. And p plus 8 represents the total number of inkjet papers because she bought 8 more than laser. Total number of inkjet bought. Of inkjet paper. I feel like I'm in the office here selling paper. Who knows? Interpret the expression 8p plus 6.95 times p plus 8. This expression represents the total cost of buying inkjet and laserjet paper. Whoa, total cost of buying. No, total cost of, because I say that Jill bought, of inkjet and laserjet paper that Jill bought. It's kind of a weird one. That's okay. That's okay. Here's what I want you guys to do. I want you just to take a second here. It says interpret the expression corresponding to the given context. You know what we got to do. You got to pause it. Next time, not the next part of this video, but another video very soon, it's going to have a little bit of fun going on for this one. Okay, so go ahead, pause, take care of numbers 3 and 4. Awkward silence. Okay, here we go. George is buying watermelons and pineapples to make fruit salad. Ooh, I love fruit salad. He buys W watermelons at $4.49 each and P pineapples at $5 each. What does the expression 449W plus 5P represent? Well, 449W is the total cost of watermelons because he buys W watermelons at $4.49 and P pineapples at $5. So this 5P represents the total cost for pineapples. So in other words, if I add it together, it's the total cost for W watermelons and P pineapples. Alrighty here, Sandy buys 5 fewer packages of pencils than P packages of pens. I think that's a tongue twister. Pencils cost $2.25 per package and pens cost $3 per package. What is the expression 3P plus $2.25? times P minus 5 represent? Again, we're only using one variable, but we can do that because it's just she bought 5 packages fewer of pencils than P packages of pens. Well, 3P, well, $3 is the cost per package of pens, and P is the number of pens that we bought. So 3P is the total cost of pens. P minus 5, that represents the cost of the number of pencils that we bought, the number of packages of pencils, because it's 5 fewer than the pens. P represents pens. I know pens and pencils both start with P, so it's not probably the greatest example, but it's P minus 5 because that's how many pencils I bought. 5 fewer packages of pencils than pens, and they cost $2.25 each, so hence $2.25 times P minus 5. And what does this expression represent? It's the total cost of buying pens and pencils. Okay, here's what we're going to do. This explain to, I'm going to give it some more context at a later time. I'm not going to include it in this target. There's some other stuff that we're going to talk about later on that will give this more context. So I like to just move on from this one. This is the end of part 1. If you look at practice 1, there's a part 1 specific practice. That starts on page 49. Oh, I forgot. I almost forgot. We got this operations business in here. We do have this. Modeling expressions and context. I forgot. This right here. Take a look at these things. This is something we've been kind of getting towards. This is something we've been getting towards when we've been doing the the discussions we've had, especially on writing equations, right? Operation is addition. What words mean these things? We've got these in here. So take a look at these. Sum, added to, plus, more than, increased by, total, all together, and can indicate addition. Subtraction, less than, minus, subtracted from, the difference of, take away, taken from, reduced by. And you got some examples over here. Multiplication, times multiplied by, the product of. That's an important one to remember. Product of and percent of. And division, divided by, division. Quotient, that's not a common one that you've always heard. And divided into, or ratio of. So what we're going to do is look at these 2 examples right here. And look at these 2 examples. It says write an algebraic expression to model the given context. Give your answer in simplest forms. The price of an item plus 6% sales tax. Now you got to understand how sales tax works to make this question work. So this is not an example that I would give on a test because I don't necessarily know that you know how sales tax works, and that's okay. That's what we're going to work through this, okay? So the price of an item is P, and sales tax is figured by multiplying 6% in Michigan times the total cost of whatever you bought. So the expression is P, that's the price, plus the tax, 0.06 or 600ths times P. You add those together, you get 1.06 P. The price of a car plus 8.5% sales tax. So that's the price of the car plus 8.5% sales tax. And so what's the price of a car? We'll just call that P. And here's the kicker on this one. What is 8.5% as a decimal? You know that it would be 8.5 divided by 100. When you divide by 100, you move the decimal place twice to the left. But there's no value there. So what do? You got to put a 0. Plus 85 thousandths, 0.085, times P, or just P. So the algebraic expression is P plus 0.085 P, or 1.085 P. Okay, I am going to kind of skip 7 and 8 here on the reflection and get right into the your turn. Okay. It says, write an algebraic expression to model the given context. Give your answer in simplest form. The number of gallons of water in a tank that already has 300 gallons in it after being filled at 35 gallons per minute for m minutes. That's a lot. That's a lot. Let's look here. The number of gallons in a water tank, okay, that already has 300 gallons in it. So we start with 300 gallons in, and to that, we're going to add, because it's being filled at 35 gallons per minute, times the number of minutes. Do we know the number of minutes? No, we do not. 35 times m, that gives us our expression. Number 10 says the original price P of an item less a discount of 15%. Less, what did less indicate? Less was, let's see here, less indicates subtraction. Think about it, right? If you're getting a discount on something, you're not going to pay more. I hope you don't pay more. If you're getting a discount on something, you're going to take some money off. We got some subtraction going on here. So I've got the price of an item, P, and from that, I'm going to take away 15% times the total cost of the item, or the original price. And if I subtract that, that's like 1 minus 15 hundredths. This would give me 85 hundredths P if I simplified that all the way out. Okay, using this knowledge, now you can do the practice from part 1. It is on Google Classroom as well. It starts on page, I believe, 49. 49. So it includes all the things we've talked about, and not the comparison stuff. I'm again going to do that later on. So hope you're having a great day, great night, whatever time it is you watch this. Take care. Have a good one.